It's time to get some gear installed. Get some cables run, wire tied, looking pretty. A lot of people call this rack and stack. And I've got to say, I know I've probably said it more times than you care to hear so far, but I am so psyched about this series. Just the more it goes, this series is actually the first of its kind. I don't know if CBT Nuggets is going to go a lot more in this direction. This is really a beta test. This is what I would call a living series, meaning CBT Nuggets has now started moving in the direction of releasing these nuggets as they are recorded. Previously, I would record an entire series and then there it is. You know, people would get the series and watch it and they go, oh, now I know a lot about routing or switching and that kind of thing. Well, this is totally different because what I did was I said, let's make this kind of like based on you guys, based on people that are hanging out listening to these nuggets, and I said let's do a survey, kind of like a pulse as we're going through, and have people direct the series. We asked a question, and it's funny, the amount of feedback I've gotten on this is insane. Look at this. This is just on Network Core, and you can see this is, what is this page? 8 of 31 of comments that I've been going through, where people are saying things like, I'd like to see cabling, rack mounting, subnetting, IDF, MDF, cabling, rack. I want to understand that more. Another person jumping in saying, where was it? Oh, I don't have experience rack mounting, cabling equipment. Be interested to see the perspective. So what I mean, literally, I'm just going through. If you look at all this stuff, there's, I mean, you guys are never. Please never type with the caps lock key on. It just makes people feel angry. Especially, he said, in my opinion, this has nothing to do with the CCNA. I seriously want to bring this up because this is good. I want to make sure I set everybody's expectation. Nothing on the CCNA exam that this first nugget deals with, I don't think, which is true, and that's one of the things that. Well, I'm not going to say nothing. Let me stop right there. There is. I would say this spirit, this series encompasses the spirit of the CCNA. You're going to see a lot of stuff in here that is on the CCNA. You're going to see a lot of stuff that goes beyond the CCMA. Some that goes into the CCNP. Some that, just like this they're all anonymous. So this fellow with the caps lock key on thought it's on CCDA. There's a lot of design in here. What I'm trying to do is put together the biggest real world nugget. I mean, like, look at this. I'm looking at this. 20. What is the point of passing the CCNA and then getting a job to be extremely confused? Thank you, whoever this is. This is brilliant because that encompasses the spirit of what I'm trying to do here, because I've seen so many people get certified, but when they get to it in the real world, they go, wow. I know how to change the host name. I can set IP addresses. You know, I know the iOS global config, show commands, but just putting this all together, oh, it's totally, freaked me out and that kind of thing. So just going through a lot of these responses of just, topics upon topics. So if you haven't filled out one of these, and maybe by the time you're seeing this, the entire series is done and it's cemented of what it's going to be. But these are freaking awesome. This is really good stuff to really, like, how do I even start if it's not set up? How do, where does the NAT come in? So just, now I will say, and I've been going through these things, and some people have been saying, is this the one? WAN technology, MPL, no, there was another guy who's like, I'm converting my network from WAN links to BGP and MPLS, and I want to know how all the BGP and MPL, I'm like, whoo, buddy. I mean, that's awesome, and I'd love to go there, but we got to scope it in somehow. So what I'm doing, I'm kind of bringing it back here to the rack and stack, the physical side of getting this set up. This is actually one of my most favorite things to do. I don't usually get to do it. Usually I get called in when something's very broken and I have to fix it, and it's all command line sitting at a desk, bending my brain to make it work. So the ability to just sit and rack mount and run cables to where they're all perfectly, I love this. I love this picture right here. I love good cable wrapped runs. Anyway, what we're going to talk about here. Where's my pen? We're going to go through the wiring, bundling cable, talk about what that is, how to do it. How do you wire a building if it's not wired? Patch panels, punch down tools. What do you need tool wise to bring this up? What kind of racks are there? I'll show you some pictures of a deployment I just did where I used some surface mount racks. They're amazing. So I've talked about mounting the gear. These all kind of go together. Excuse me. One of the One of the things I saw in the survey was someone said when they got out of the CCNA, they got their CCNA and they got to the job, and they were surprised at fiber optic cabling. There was really nothing about fiber in the CCNA, rightly so. Well, I shouldn't say rightly so. It's not there. They maybe mentioned there's this cable called a fiber cable, but I'm going to talk about those kind of connections. Wireless access points. How do you pin those things to the ceiling? What's the best way to do it? How should the antennas be pointed? That sort of thing. And then finally, someone, and this is pulled straight out of the survey. I'm serious, guys. I am taking your lead on this series. When you're telling me I've seen a lot of Stackwise. Someone said I've never seen Stackwise before I started my job, and that kind of confused me. I didn't get what that was. So I want to talk about Stackwise and where that fits. Whew. So can you tell I'm excited? I need to slow down and breathe. My wife always hands me a paper bag. She's like, "You're hyperventilating again, Jeremy. Slow down." All right. Well, let's talk about building, wiring, cabling, ISP connections. How do those come in? All that kind of stuff. I want to kind of group that together here. So first off, we're in that empty building. Remember, I started this whole series saying, okay, empty building. We met with the management. They outlined what they wanted for the building, how things were going to be set up. We created the design. We ordered the equipment. Now, what about the wiring? So in our scenario, I told you that the building was pre-wired. The contracting company, what was it? Grabber, something. I can't remember the name of the construction company. But they pre-wired the entire building to get everything connected. But there's a lot of times you will have to run an extra wire or extra cable, or sometimes you may have to cable the whole building yourself. So here's the idea. You've got network cables, obviously, and I'm not gonna go too low to where I know you guys have seen a network cable before. It looks like a phone jack, RJ45, and on those Cat5, Cat6, all the different kinds of cables. But I really want to go more big picture than that. Our goal is to get every single device. Let me fix my tablet here. Every single device cabled and connected to our switching infrastructure. Now we're going to do that through running the cables through patch panels, but on the back of every single computer, you flip the computer around. You can't get a computer nowadays without a network card. So that network card will come, and that will plug into a wall jack termination. Now, I'll show you close up on these on the next slide what this actually looks like, how to wire it in. But the construction company would have beforehand gone and pre-wired Cat5 cable. You've got, again, 100 meters maximum. I'm thinking megabits per second, 100 meters, maximum distance between the PC or the IP phone and the switch. Those run up through the walls and all come back to a central point. A lot of people call these cable runs, where now this is a very large company, obviously. This is kind of fuzzed out, but you can see all these cables coming in. This is kind of the central point. They all come down. They're all very well wired managed, at least from what I can see on here. And these all link in. It looks like, just again, it's hard to see from this picture, but it looks like they're all punched into the back of these things called patch panels. The patch panels really act as a junction. They are the first point of termination of the cable. So if you could visualize with me, let's say this is your MDF, right? The main point where everything comes in. This is the room. And so you have all of these computers from all over the company. They've got their cables going into wall jacks. And this is what those wall jacks look like. A lot of them call them Keystone. That's just one of the major vendors of wall jacks. Matter of fact, I'm going to take you to my favorite website for everything cabling and jacks and testing equipment. It's Monoprice. I'll show you that in just a second. But all of these things, run from the wall jacks of the computers through the ceilings. A lot of times, raised ceilings or not raised. I'm thinking raised floors. The what are they called? The little ceiling panels that come off. They break all the time when you drop them and are painful. Well, anyway, all the cable running through the ceiling, coming down to the patch panel, which usually looks like this. Doesn't have any power or anything like that. It's just the junction point. And what it looks like on the back is this. Now remember, every single Ethernet cable, when you look at that Ethernet cable, I should bring that last slide up, it actually has 8 individual wires inside of it. Here's your individual jack. So we take the cable from the wall jack that comes in here, and if I could kind of zoom in on these things, matter of fact, let me do that. I'm going to take you right now to Monoprice. Okay, so this is a place I stumbled on a couple years ago, and they changed my life. Seriously. They're in California, which is just right next to me, a couple hundred miles away, so I get overnight shipping cheaper than normal shipping from them. But that little side note, they have networking stuff cheaper than anybody. I mean, not even like half off or something like just amazingly cheaper. So, for instance, if you want like Cat 5e network cables, they've got every. I feel like I'm like selling Monoprice. I'm not. I should get a discount from them, but look at this. I mean, like little half-foot cables for 55 cents, or if you buy like 50 of them, they're 42 cents each. Which every color, every shape, every size, and they've got every length. I love this place, and seriously, I know some people are always skeptical. I am. They're like, "All right, are you just trying to?" I get nothing from this company. I just use them all the time, and they're great. So anyway, what I'm looking at here is the Keystone Jacks. Modular connectors. That these guys are what are actually in the wall jack. This is a much better visual than that tiny one on my slide. So let me go to the large more view. So you can see right here, it's upside down, but you actually have the cable. There we go. That comes in right here, your network cable, Cat5 cable, and then you take each one of the 8 individual wires and push it through this scheme. And you can see right here, looking at the side of this, almost everything has this. They have a color code of if you're using the T568A standard or the T568B standard. Those are just 2 wiring standards of how it should be. When I first got started networking, and I don't know if you did the same thing with me, but yeah, let me go back to the other slide here. Here we go. When you come on, confess if you did this. When you created your first network cable, if you were like me, you're like, okay, as long as I make them match on both sides, it should be good. So like orange stripe orange, green stripe green, blue stripe blue, brown stripe brown. As long as I match it on both sides, it'll work. And it's true, it will work, but it will never go 100 meters because inside of the cables, they actually spin all those wires together. They twist them. That's why they call them twisted pair cables. So they twist all these cables together in this certain way, and I mean this is where an electrician, a mechanical engineer genius, electrical engineer genius would be able to explain that when you send the electricity down, it actually spins the electricity. Or the electric signals, it's not electricity, the signals, it spins the signal through those wires, and it creates kind of like an electromagnetic shield around the cable. So you have to set the right colors, or else you'll only have a cable that goes, when I first did it, I crimped on some ends, and it worked, but only about 10 to 20 feet was about the maximum distance, and I thought, I'm doing something wrong. I was. I have to go and cable it with the right standard. So see, where was I? With Monoprice. T568A is one standard, B is the other. If you have one side be cabled with T568A and then the other side you make a B, that's where you have your crossover cables. It looks like, oh, look at this. This even comes with little snap-on plastic guards. So once you get the pieces in there, you're good to go. So these are what actually go in the wall jack. So right here at the computer, you've got your wall plate, and they sell. Where's my Monoprice? Let me go back here. They sell wall plates, and you can get all kinds of different kinds. Like this is a 3-piece kind, so you literally snap those little keystone connectors, whatever they call them, the keystone things, into those wall jacks, into those plates, and then mount them to the wall, and that's where the computer plug in. Now, let me go to the network tools, because I want to talk about some of the tools. I just brought up this toolkit because it had everything, and I thought, well, that's good. They have all kinds of tools on here. Let me go down to that toolkit so I can talk about all of them. And you don't have to, I'm not saying buy this toolkit. I'm just saying I want to talk about the individual pieces. Right over here, if you look on the right-hand side, it's called a punch down tool. That's what this guy is right here. So this, you can see, and this is the tip that we're looking for. You put this little tip into the punch down tool, and this, you can actually, these little dials control the pressure and how hard before it like snaps and things like that. But this tip actually has a little razor point on the edge. So what you do is you take this guy and I should just go back to the slide here, you actually punch each one of, that's why they call them a punch down tool. You take each one of those individual 8 wires and push it down into those little slats, and it makes a connection with the little copper connectors or whatever metal they use. I think it's copper inside of there, and that's what now bridges it to the front. So when you plug in a cable, all of the wires are bridged to the other side. So that's one of the key pieces that you'll need. They have some looks like some snips here to kind of snip off the wire. This up here at the top is a crimper. Where you can, oh, look at that, different kinds of tips that you can crimp. RJ45, we would snap that little guy in there, and you just, that's when you are wanting to actually put a tip on the cable. So you've got your raw wire, and you can buy the little plastic tips, put it on there, smoosh it down with the crimper, and get it on here. Now let me talk about some really key things in this kit. Let me see, oh, here we go. This is a wire stripper and cutter. They got a little blade there. What am I looking for? I'm looking for, wow, look at that. I'm looking for this. This is a, looks like a cable tester where you can test and see if all the wires are matched up on each side, and then a tone generator. Come on. If you got into Cisco before you got into cable, the first time you saw a tone generator, wasn't it the coolest thing in your life? I was doing Cisco. I know it sounds weird, but I was doing Cisco for like 4 years before I ever got into cabling. And I went to a site, and there was a guy there who was toning cable. I'm like, what are you doing? You know, I don't want to look stupid, so I'm like, yeah, so yeah, what you got there? You know, I'm trying to sound smart, but the guy within 2 seconds is like, this guy has no idea, and he's like, oh, let me show you, and he's showing me how you actually can, you know, if you're wondering, okay, well, where does, you know, I've got this cable and it goes into this giant bundle of hundreds of cables, where is it terminating over here? Well, that's where you can, you know, take one of this, clip it onto the end. It's got little alligator clips. Clip it on the end or plug it in, and it'll generate tone. And you can take your little magic wand and come over here to the MDF where all of that cable terminates. Everything comes in, and run it over that, and you'll be able to hear, you know, which cable actually is getting the tone. It can go through the shielding on the cable, and you'll be able to tell. So again, first time I did that, I was like, that's amazing. Nowadays, I'm like, oh man, can someone else tone this cable for me? It's a hassle. It takes some time. So we're coming in. We've got our computers that are running through the ceiling. You've got your tools to punch down the cable into this. This goes into the wall jack, runs through the ceiling, comes out into the patch panel, which think of all your cables coming into here. And that it literally, on the back of the patch panel, this is what it looks like. You take and you punch down each one of those individual wires from the cable into a jack. And then you patch it. You buy just little short cables to patch it into the actual switch. Now, you don't have to do it that way. You could take all these cables, put little tips on them, you know, crimp little tips on them, and run them straight to the switch. But the problem then is you don't have a junction point. Like if you ever want to move the switch or something like that, it becomes a major hassle. And then you have, you know, the wire's too short, you can't do it, you're pulling really hard to get it out of the ceiling. Those of you who've done this before, you know what I'm talking about. So this gives you a junction point, to where you can buy whatever length cables you want to go from the patch panel into the actual switch. So here's a good picture of the end result of this. Now I took this picture from a company called North Florida Communications, who looks like they just do a bang-up job with cabling. Looks great. So right here on the right-hand side, these are all our patch panels where the cable is coming in from the ceiling, you know, not shown here, probably on the back, coming in from the ceiling, goes to the back of this, and then these are all the individual, and let me move my pen to the right place. There we go. These are all the individual patch panels where I take each one of these and plug them down here into the Cisco switches. So these cable bundles that are coming in here, I'm assuming are coming from the patches that come in from the wall and then come down here to the switches. Now this is a big network. You know, this probably, you know, looking at that, you know, to about 100 devices or so are plugging in there. So, you know, that's again what the cabling is going to look like. Looks like we've got a few routers and stuff up here, but that's a larger network typically where you have this size of racks. I've seen a lot of these. These are great little wall mount units where you can have it looks like the cables are coming in to the top right here. You see the little holes in the top. Run down here to the patch panel below, and it looks like they've got some kind of, I don't know what device that is, but maybe it's a router, swouter, switch, everything all in one device is what it kind of looks like, where everything patches up do that. A little wireless device down here or something. Can't tell what that is, but those are great. Little looks like 10U, 12U units. That would be, this would be our MDF where everything's coming in. This is like a little IDF. In our scenario, this would be the first floor. This would be the second floor. Where that's plugging in there, except we would probably have a lot more cables coming into our little unit. I wanted to show you one more thing. I actually found these racks about a year ago, and they're so great. I got them from a company called Gruber. That's where I got Grappler. That was the name of our cabling company. They are I can't even find them right now. They're I think they're about $30 for this rack. This is actually, I took pictures. This is a job that I did. This is me, where I went in, and this is some Cisco small business gear. This is actually a church in North Scottsdale that I set up for them. This is one of the locations. It's a little 3U. 3U rack mount that mounts them flush like this. And what I did, this is actually a picture from the top view of this. What I did is all the cables came in from the wall. You can see them coming in from the ceiling right here, and this is blank right here. There's nothing in the back of that rack. Back here. So I kind of dropped the cables in, and then this is the patch panel. So I've got, if you're looking at U's, this is 1U of space. This is 1U of the patch panel. And then this is 1U for the actual switch. So I have everything coming in, punching into the back of the patch panel. This cable right here is actually I used orange just because I wanted to know that was special. That is my link between two buildings. And then the patch panel runs to the actual switch. Now what I did here, and this was fun, I set them up with an ASA 5505. And the way I mounted that to the wall, it is they sell like a $70 or $80 wall mount unit for the Cisco ASA, and I'm like, whatever, keep that. So what I did was I went to Home Depot, just peeled off the little rubber feet on this guy, and got some industrial grade Velcro. I know some of you will say, well, I did Velcro once and it peeled off the wall. Well, what I do is I put the Velcro on the wall and stick it to it. It's really sticky, but then I take some Phillips screws, and depending on how heavy the device is, I'll just go bzz, 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 and just screw it straight into the wall. Don't even need any anchors for the wall or anything like that. So zip that Velcro on the wall in there, and then I use 2 strips to mount that ASA 5505. I'm telling you, it's not coming off. It's not, even if you want to pull it off, it's really hard. So that's the firewall, and then this is a little cable modem. And I did it this way. It worked out so well because with this surface mount, flush mount rack, I was able to hide all of this stuff behind there to where that's all mounted to the wall. The switch really covers most of it. This is another building on the same campus. This is actually where that orange cable goes. I'm not done. I haven't actually punched all this cable down right here. So don't begin pointing fingers yet. You do it too. It's not done yet, but that's an example of another one. So those mounts really worked out well for me. Okay, so now let me address that comment that came back from the survey that people were filling out. That actually a couple people said when they got into their workplace, after getting the CCNA, they got hit with just a ton of fiber stuff, and it confused the daylights out of them for a little while. And I will tell you, I was absolutely there as well. I actually feared fiber. I would go down to the data center, and there would be someone who's like, "Oh yeah, we'll connect these 2 cabinets with fiber, and why don't you just get the SFP for the multi-mode connection?" It was just, I kind of look at him. Can you just, what do I buy? What's the part number? You tell me the part number, I'll order it, I'll put it in. Because fiber just had that like mystical, it's light, it's weird, I can't punch it down with my punch down tool kind of thing. Same feeling I had when I first got into cabling. I was like, what's the toner do? So let me give you the flyby. Here's what you need to know about fiber. First thing, there's 2 major categories of fiber: multi-mode and single mode. Multi-mode is, I guarantee, probably what you're going to work with most of the time. It is a shorter distance. For instance, I just pulled up Wikipedia over here for multi-mode fiber. This is kind of a view of what it looks like. It's very, very thin, but not quite as thin as single mode. But you're looking at 10 megabit per second to 10 gigabits per second, and who knows, by the time you're watching this, that could have even gone higher, for lengths up to about 600 meters. Now, you'll find some conflicting documentation out there. You know, some will say, well, multimode goes for miles or kilometers, and I'm saying today's standards, it's about 600 meters that you get for multimode fiber. So that's a decent distance. That's connecting a couple buildings together. You know, that could be connecting, you know, really far, you know, ends of the building, like our IDF to our MDF. And the fiber is cheaper, and the SFPs, the actual interfaces for it, are cheaper because they're not as precision oriented as single mode is. Now, single mode fiber is going to be where you're going miles or kilometers, like 3 to 5 miles kind of distance with your fiber runs before you have to install a repeater. Now, with fiber, one of the benefits is that you can repeat it unlimitedly. That's what's making fiber the link of the future. Is you know, now you've got Metro Ethernet, where they're connecting major metropolitan areas like hundreds of miles apart together with fiber, to where eventually our nations, I guarantee you, nations are all going to be connected on fiber, you know, within the nation. You know, once you hit the ocean, who knows, you know, if they'll ever figure anything out for under ocean fiber optic links. Who knows, maybe it's already there and I just don't know about it. But single mode is very, very thin fiber, even more thin than our multi-mode optical. And it uses a single light ray versus multiple ones on the multi-mode. So when it comes to you, I mean, you can, and I will tell you, Wikipedia is fantastic. If you really want to dig in and say, okay, well, how did they do it? How did the light work, and all that? And I will tell you, it just does. I don't get into the laser, you know, all of the, you know, for me, I'm like Austin Powers, you know, when Dr. Evil comes out, he's like, it's a laser, and so that's kind of what I do. You know, I use laser pointers, so it's kind of the same thing, right? So you've got the multi-mode single mode fiber. You want to go get the correct SFPs that match which one you're going to be using. They sell, you know, short haul, multi-mode, long haul, single mode. You know, you got to go buy the right SFPs, and that's really the main differences. But again, the sales rep a lot of time will point to the right one. The one thing that did surprise me was the price on these things. Again, US dollars, you're looking at $200 to, well, could be $500 per SFP, depending on single mode, multi-mode, all that kind of thing. They're more than I thought they would be. You know, I'm preparing myself for like $20, $50 maybe, and then I priced it out. I was like, wow. Now keep in mind that is for the Cisco ones with the Cisco logo on it, which makes them just more expensive just based on that. You can get them aftermarket. Matter of fact, I just bought a batch of 10 multi-mode SFPs for, I think I paid $20 a piece for them. But I will say, just if you hold one in your hand, you know how it's, you tell how valuable something is by how heavy it is. You hold one of those $20 one, and you hold the Cisco one, and just right then, I mean, it's like pens, right? The little big pen versus the I don't know, it's a fancy pen, the heavy ones. You can tell there's an immediate quality difference, and I can say my little Quantity 10. I bought them about a year ago. 2 out of the 10 have gone bad already, to where they just died. You know, they stopped working. And I guarantee you, I've got plenty of places that bought the Cisco ones, and they just keep going. So you do get what you pay for, so watch out for that. You want to also get the correct patch cables. And where do I go for that? Monoprice. Da, 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 da. Man, again, compared to the other places, go to the networking. Let's see where we got. Fiber. Where? No, maybe home. Fiber optic cables. There we go. And they have, if you look at this, every single kind, again, every shape, size, every kind of connector you want, every distance that you want. The big one that I usually use, let me see if I can find it. Well, I'm going to take the time now. I use it for most of my Cisco switches. See if I can. There we go. This guy. A lot of times when the company comes and patches it in, they will terminate it to a patch panel that has these kinds of connectors. the LC connectors, and then our Cisco switches. Most of them, again, I shouldn't even say most of them. There's a lot of different connectors, but most of them just use these mini SFPs, and you just snap that in there, connect this to the other side. One of the things, and I will say, if you haven't dealt with fiber at all, they do have a transmit and receive pair, and they have to match between the two sides. Now, this is, I know, this is from the field advice, right? How do you know, let's say you're sitting there, you got the patch, you got this cable coming in. How do you know what the other side is? I'll give you the quick go blind in a couple years kind of tip that I use all the time. Essentially, one side will have the transmit and receive. The other side has to be flipped, right? So one side will be sending on this, and it has to match to the receive on the other side, and then this side will be receiving. It has to match to the transmit on the other side. So you essentially have to flip this, right? So blue matches to red if that were the opposite colors. What I do a lot of times is I never know which one it is. Some people label them with the sticky tape and all that. I come into the side and I literally connect this patch cable and I look with my eye. Yes, it's on the warning label. Don't do it. Don't follow my advice. I look with my eye and I see where I see the red laser from. It'll be red. One of those sides, if you look really closely, sometimes you got to shield it with your hand so it's dark. One of those sides will be red, and you want to look in your switch. Yeah, literally in your switch, you'll be able to look in the SFP. Again, I know there's someone who's medical out there, and they're like, Jeremy, don't say this. That I do. I look in there. I try and look at an angle so I'm not totally going blind, because it does blind you if you look after a while, and you'll be able to see which side has the red light. And what I do is I just match. I say, okay, well, the red on this side has to match to the non-red on this side, and so I flip these cables if they need to be flipped. Yeah. Forgive me. I know somebody out there is groaning right now. Knowing the colors. And one other thing that you'll be able to tell, and this is great if you're on the phone with somebody and they go, I don't know what kind of cable this is. You're trying to order the right SFP. You can just ask them, hey, is the cable orange? Is it aqua? Or is it yellow? Orange, and this is a standard I found, just about everybody follows it unless you're really going off brand. Orange is typically your multi-mode. The yellow is your single mode, and then the aqua is usually when you're into the 10 gigabit per second fiber optic, that usually connected to a server or between two switches, little patches going between those. Those are usually the multi-mode or sometimes single mode that have that aqua color. So hopefully that was valuable for those of you that haven't seen the fiber world before. And I'll tell you, once you get used to it and it's demystified, I think half of the not wanting to work with fiber is just the fear of, oh man, I'm going to order the wrong pieces, I'm going to blow up the switch, wrong SFPs. Once you get it down, it's overwhelming when you surf the web and say, what do I need? Because there's so many different connectors and styles and all that. But again, once you boil it down, it's not too bad. So now let's wrap up. Let's talk about two more quick topics: wireless access points and StackWise. The wireless access points, this is actually a picture of the 4410N, the little small business series that I was mentioning the business wanted to buy. Here's my tips. Try to keep the antennas at 90-degree angles, meaning have them go straight up and down. Or straight flat, to where these guys are either straight up, or you lay them down. When you take this one down, it looks like this. It goes flat like this, and then you can mount it on a wall or something like that. The reason why is just how the wireless works. You don't want to start putting it on weird angles, like tilting it 45 degrees, stuff like that, because it's not going to be as efficient as if you would have kept the 90-degree angles. And every access point, when you look at the directions, will say, we recommend mounting this flat this way or horizontal this way. They all have their own little ways to mount them. So you've got the 90-degree angles, first piece that I was mentioning. Avoid absolutely anything that has metal in it. You'd almost be better off going through a concrete barrier. Well, I shouldn't say almost. You would be better off, because metal absolutely reflects and distorts your wireless signals. I've come to many organizations, and they have really poor Wi-Fi, and you come in there and you find out they've got it in the filing room. It's sitting on top of a filing cabinet, and you go, ah! I mean, literally, if you take one of these and set it on top of a filing cabinet, all your wireless signals are being reflected and shot out directly into the ceiling of your organization. So try to find, it's not always possible, but try to find a place without metal to mount these guys to get the clearest amount of vision, and also know, or a clear signal, but also know that if you do have areas that have a lot of metal, you're going to need more access points. Now, one of the advancements with 802.11n, 802? Is my brain checking out? No, that's right. I don't know why I was thinking 803 for some reason. So 802.11n gives you MIMO, finding MIMO, to where you have multiple inputs, multiple outputs, whereas previously you didn't have that. And the more reflections and scattering of the signal you had, the worse your signal was. Well, 802.11n changes the rules a little bit and can actually benefit from some of the reflections. So you may find a little better reception and availability if you just swap out your 802.11b and g access points for 802.11n, just because of the multiple antennas. Avoid metal. Just a flyby story on that. I got my house stuccoed. And for those of you that don't live in a desert climate, stucco is where they take your house and they put, oh, I don't even know what stucco is. It's magic. It's like cement or something on the wall and painted. I don't know. Hang on. Okay, here we go. My house does not look like this. That would be awesome. And you don't have to have a house like that to have it stuccoed. Mine is much smaller. But it looks like this. So anyway, stucco isn't the matter. It's the fact that when they put stucco on, the way they do it is they actually put chicken wire on the outside of your house, and then they put styrofoam over it and all that kind of stuff. And then they put the cement, the concrete, the whatever stucco is, onto the chicken wire, and that's what holds it all together. So the chicken wire itself was enough to totally mess up my wireless signal outside. I actually had to buy another access point to get a good wireless signal outside of my house because it just gets so distorted by the chicken wire. So when you're placing access points, you can mount them in the ceiling where people can't see them. You can mount them out of the ceiling to where they can be seen. But you want to make sure that you have a 20 to 30% overlap in your wireless cells. This means when you're placing your access points and you've got your laptop or your Fluke Networks wireless widget, whatever you've got, you'll get a radius of Wi-Fi signal that it reaches between the two. So you want to make sure that these overlap. Like this is your access point. You want to make sure that these guys get a 20 to 30% overlap so that roaming devices don't lose the signal between those two. So we've got all of these guys going together there. Now, when you do that, and this was when I first got into wireless. It's funny. I just feel like I'm sharing every painful thing that I did. When I first got into wireless, I didn't know much about it. So I thought, if you're doing this, you want to put them all on the same channel so that people, they all kind of talk and they don't lose signal or something. It just made sense in my head. I'm like, they should be, to make them all compatible or something, and they are on the same channel. No, that's exactly wrong. Wireless Wi-Fi. And I'll say the 2.4 gigahertz spectrum, which most people use, has 11 channels that you can use. 1, 2, 3, 4, 5, 6, 7, 8. But when you're looking at the wireless signal, the wireless spectrum, or I should say frequencies, like for instance, channel 1 might go between these frequencies. Channel 2 does this, so it actually overlaps with channel 1. Channel 3 does this, so if I were putting the channels under here, it would be 1, 2, 3. Channel 3 overlaps, and so you get overlap in all these. So really, the only true clean channels that you get is these are where it ends. You've got 1, 6, and 11 of the wireless signal. If you have 1, this guy on channel 1, this guy should be on channel 6 or 11, so it doesn't overlap and interfere at all with the other ones. So it's a challenge, and that's why those wireless controllers, I mentioned that in the design, the wireless controllers are so handy because they figure all this out for you. You just kind of plug the access points in and they do the rest. But One thing I will say is sometimes, especially when you go with multi-story buildings, multiple floors, it's very difficult, because when you're on a 2D diagram like this, you're like, okay, I can do this. So this will be 11. This will be what 1, 6, 11, 1. 1, we'll say, and this guy will be 11 over here. You're trying to keep them all clean or whatever. I'm like, it's easy, and I'm totally falling apart, right? So it is easy on a single floor to do it, but when you add multiple floors and you're like, okay, I've got 6 up here and 11 down here, but I've got 6 right here, and you're trying to coordinate it all, it's like, it totally fries your brain. So that's where the wireless controllers just figure it all out for you. So last thing I'll mention on this is if you have to overlap, meaning you can't get a clean channel, don't pick one of the ones in between. Don't do like 3, because that first off takes out 2 of your clean channels by doing that. But it is better, meaning the wireless access point is able to handle the collisions, or I should say the interference more, with a wireless access point that is on the same channel than it is with one that's slightly off. So for instance, if you've got 2 overlapping cells and they're both on channel 1, that is better than having this guy on channel 2 or 3 or 4 or something like that. Something that's conflicting but overlapping, because the access points aren't able to detect anywhere near as much on these other channels, and they just have garbage communication that happens when you do that. So that's, again, the flyby view of how to place wireless access points. And the last thing I'll talk about is StackWise. Thankfully, this one's really easy piece of cake. It's just odd if you haven't seen it before. This is something Cisco came out with some number of years ago, which allows you to almost build your own chassis-based switch. To where, normally you have, switch 1 managed completely independent of switch 2 and switch 3. I've got switch 1, 2, 3. Each one has its own IP address. You manage them independently. But StackWise not only combines the switches together physically, like this becomes your crossover cable, if you will, but it actually combines them logically as well. So first off, you're linking really the backplane of the switches together when you do this. So there's no more like, oh, well, I've got a 1 gig link going between these switches on a crossover cable or something like that. The StackWise combines the backplane, so you're getting full bandwidth between these. It really is like a chassis-based switch. And they're administered as one. You can give them one IP address. And these are now seen as modules. Like maybe this is modules, all the ports are 0/1, 0/2, 0/3 on that top switch. Then the second switch will be 1/1, 1/2, 1/3 on the second switch. This one's 2/1, 2/2. So you're actually administering them just like you would a 6500 or a 4500 series switch, the big chassis-based switches. And it combines all of their logic into one. Very handy, also becoming very common. I've seen a lot of these. And some of them even have power sharing, to where like if this one loses a power supply or something, it can get power from the other switches that are in the stack. It's amazing what they've begun to do with this. So that's really all there is to StackWise, is you're combining these switches physically and logically and administering them all as one. Like drinking from a fire hose, right? Well, if you've ever cabled a building before or anything like that, I will tell you it's a trip. The first time you do it, it's going to be confusing. Seeing it right here is one thing, but actually taking a punch down tool and punching it in, and then you go, oh, I punched it the wrong direction. It should be coming from the inside. I mean, I've made just about every mistake that you can make in cabling, but it's, after you get past the frustration, it really is. It's well, I know some of you are like full-time cablers, and you're like, I don't like cabling at all. It's miserable, but for me, I enjoy it. It's very stress-free. There's not one command you can type that takes down the whole network, but you can loop the network. I've done that before. So anyhow, we'll talk about that later. We have seen, just again, the flyby view of wiring, bundling cable. Oh, I'll give you one more tip. Use Velcro. Again, Monoprice sells spools of Velcro for like $2. Velcro tie these things. Try not to use the wire ties that, the plastic ones that or the zip ties, that's what they call them, that you are permanently stuck on there. Velcro is much better. So Bundling cables, we saw the patch panels, punch down tools, some of the rack options that you have, the wall mount, the flush mount. They have cabinets, they have the two-post rails, mounting the gear, putting it in the rack, going along with that Visio diagram I was talking about with the in the design. Fiber optic, hopefully demystifying a little bit of that for you, so you're able to say, okay, I understand SFPs have to go into the switch. Those receive the fiber connectors, multi-mode, single mode. I know what kind of cables there are. You just buy the right cable for what kind of connectors you have. From there, we went to the wireless and then Cisco StackWise. So I hope this has been informative for you, and I'd like to thank you for viewing. Oh, and keep the feedback coming. If you're still in the point where this series is still going, I'm telling you, please keep that feedback coming because that is literally driving this series. All right.